So students, as promised, we are here with the most expected questions, the must-do questions of the another chapter, that is binomial theorem. We are already done with 3D geometry. Now next is binomial theorem. So again, a very important chapter, a very simple chapter as far as JEE mains paper are concerned. Okay. So now these are the questions. So again, the format is similar. I just wrote these, I'm just showing these slides. So if you wish to solve these questions, just try them once and then you can match the solution. Or if you think that there's not that much of time, so of course you can then go through the solutions with me quickly, and then you will be able to at least solve these type of questions, which I strongly believe are going to be very important and highly anticipated questions for the upcoming JEE mains sessions. So that's it, and then a few questions based on series here, and then this is really special. Okay, the last one is really special. So let's start. So now see, the first one is in the expression. See, that's a very common format, okay, which is based on the general term of the expansion. I told you in our last like short video which we uploaded with the title that most expected questions. Okay, so in there I told you that very important result for binomial expansion is this one, and which is the general term of the expansion, which is NCR a raised to the power n minus r into b raised to the power r. So the first target, as far as the target of this video is concerned, the first and primary target is to the what different type of questions you may expect from like which can be framed from here. So I'm not, of course I won't claim that these are the only type of question. You can find n number of very good complex tricky questions based on general term, but still keeping in mind the JEE mains thing. So the type of questions which you may get is, see, I combined the GP, infinite GP and binomial here. So I said, okay, in the expansion, find the value of term independent of x. Value of term independent of x. Of course, where I would have written that mod x is less than 1. Of course, I need to write it here. Okay, so independent of x. So now see, this is a GP, infinite term GP whose first term is x and common ratio is half. And here again, this is infinite term GP, first term is x by 2 and common ratio is again half. So if I write this the binomial as the first term over 1 minus half minus 3 times the first term over 1 minus half, okay, raised to the power r. So what do we get? See, it then gets simplified to a very simple form here. So which is nothing but 2x minus 3 by x, I suppose, yeah, x raised to the power 8. Now which term do we need? See, now that's a very simple binomial here, isn't that? So which term do we need? We need the term which is independent of x, the constant term. That means the power of x here should be 0. So assuming the required term to be the general term, which will be 8cr into a is the first term of binomial, 2x raised to the power 8 minus r into b is the second term of the binomial, minus 3 by x raised to the power r here. Okay, so now we have to just collect the terms, the power of x here. So it's 8cr into 2 raised to the power 8 minus r into x raised to the power 8 minus r, and then it goes to the numerator with x raised to the power minus r, so minus r into minus 3 raised to the power r here. So which power of x do we need? We need the power of x which is 0 here. Okay, so we need the power of x which is 0 here. So 8 minus 2r equal to 0. So r is equal to 4. Therefore the constant term is 8c4 into 2 raised to the power 4 into minus 3 raised to the power 4, and that's it. So depending on the option, we'll be simplifying it. So that's one term based on the general, that's the one question based on general term of the expansion. There can be several many other type, like I think I framed few more here. Yeah, find maximum and minimum value of the constant term in the expansion. So if we assume x to be a variable, so we are assuming here that x is a variable. Okay, so the maximum and minimum value of the constant term. So constant term in the expansion will be a term which is independent of x in that case. Okay, and then see again the same logic, the same thing. Let the general term, so NCR 6CR into a 3x cos theta raised to the power n minus r, 6 minus r, into b, which is minus sine theta by x square raised to the power r. So here again we will be collecting the power of x here. So what is it? So x, where is it gone? Yeah, x here. 6 minus r minus 2r, and that should be 0. So r is nothing but 2 here. So what is it? So 6c2, which is a constant of course, 3 raised power 4, again a constant, and then it is what is it? So cos raised to the power 4 into sine square theta. Isn't that, bachcho? Yeah. Okay, so now see, it's simple. Now you have a function f of theta, because this is a constant with respect to theta. Okay, that's a constant. So we have a function of x which we need to maximize or minimize here. So cos raised to the power 4 theta into sine square theta, and we all know how to do it. You will just differentiate with this, or you can even try to convert it to a polynomial form. You can replace sine square theta by 1 minus cos square theta. But anyways, if we do it, so if I just simply like differentiate it, so 2 sine theta, and then it will be cos raised power 5 theta minus 4 cos cube theta into sine cube theta, isn't that? And then equate it to 0. So whatever you get common, take it out. So it will be 2 sine theta cos cube theta, I believe. And so it's cos square theta minus 2 sine square theta equal to 0. Now see, since theta is in the interval 0 to pi by 2, both end open. So neither this can be 0 nor that can be 0. So the only possibility is that this gets 0. So from here you get the value of theta, which says that tan square theta is nothing but 1 by 2, and then from there you can get cos theta sin theta, put the value, get maximum minimum value. Okay, so that's another question based on the general term of the binomial expansion. So if you would have done the previous year question, you will find that there are almost every third or second question which has been asked in the last year, particularly in 2024, was from general term only. Okay, so that's really a very important thing. And see, what's the other application of general term? Find sum of all integral terms in this expansion. So again, what are we going to use? We'll be using the general term of the expansion. So what is it? So the general term is NCR A root 2 raised to the power n minus r into b cube root. So 3 raised to the power r by 3. Isn't that, bacho? So you will write it as 15 cr 2 raised to the power 15 minus r by 2 into 3 raised to the power r by 3. Now see, what does, see, if this term is to be an integral term, which that means is this to be an integer, then the power of 3 should be an integer, r by 3 should be an integer. So when will that be an integer? When r is a multiple of 3, bacho. Okay, when r is a multiple of 3, and when we say it's a multiple of 3, what that means? Here it means that like the numbers which occur in its table, 3 into 0, starting from 0 of course, so 0, 1, 2, 3, 3 into 1, 3 into 2, 3 into 3. Similarly, 15 minus r by 2 should be an even number. Now r is a multiple of 3 and 15 minus r, should be an integer, so I will remove this. So 15 minus r should be an even number. So what doesn't that mean? R should be an odd integer. So r a multiple of 3 and an odd integer. So doesn't these two conditions combine to give us that r is odd multiple of 3? So how many possibilities, bacho? So r can be 3. So r1 3 into 1, and then it could be 9, and then it could be 15. Isn't that 6 nahi ho, 12 nahi ho sakta. So these are just 3 possible values. You will put the values here and then find sum of the integral value. See, I just wrote the sum. Okay, so it's going to be a huge value here in this case. So of course I'm not going to evaluate it. Now neither I'm going to ask you to evaluate it. The only thing is you should know how to approach the question. So that's the approach. See, we have few better questions also in this case here. Now see, again, find number of irrational terms in the expansion. Now look at the form of the question here. Root within root. Under root of 5 minus root 24. Whenever, see, I am going to solve this, and then I will expect you people to pause the video and solve the next one from yours on your own. So root within square root. So whenever we have it, I will definitely my first attempt is to convert it to a perfect square, bacho. Okay, so for that case, see, this number is definitely to be compared with a square plus b square, and then you take it common, so you get it as 2 root 6. Okay, now if this is a square plus b square and this is 2ab, so this can be anyone's guess that a is root 3 and b is root 2. Okay, a square plus b square is 5 and 2ab is 2 root 6, and we are done. So we can write it as root 3 minus root 2 whole square. Now you can say, okay, I can write it as root 2 minus root 3, but I won't write it like that, because we know under root of t square is nothing but mod of t. That means it always gives us positive value. So under root of 5 minus 2 root 6 will be actually mod of root 3 minus root 2. So of course it has to be positive, so in any case it's going to be root 3 minus root 2. So now the binomial will be here in this case root 3 plus root 2 raised to the power 19, and the number of irrational terms in the expansion. So again here, see, general term will be 19 CR 3 raised to the power 19 minus R by 2 into 2 raised to the power R by 2. Now tell me how many irrational terms will be there. See, so let's count it in the reverse order. Again, I'll prefer to count the number of rational terms in the expansion, bachcho. So R by 2 should be an integer for this term to be a rational number or an integer number. So that means R should be even. But if R is even, 19 minus R is odd for sure. So it can't be a multiple of 2. So if I ensure that this term is an integer, this won't be an integer, this will be an integer, this won't be an integer. That means in this expansion there is no term which is a rational number. All the terms are irrational numbers. So how many? So there are 20 such terms. In any binomial expansion we always have n plus 1 terms, bachcho. Okay, so 20 such terms. Now going to the moving to the next one. So again, see, it's I think now you people can easily do it. So if you simplify it, it's 2 minus root 3, isn't that, bachcho? है ना? So 4 plus 3 7 minus 4 root 3, right? So it's 2 minus root 3 and then plus cube root of what? 2. Cube root of 2 minus 2 raised to the power 17, right? We got it. And again, see, now rest of the question is similar. So cube root of 2 minus the square root of 3 raised to the power 17, number of irrational terms. So again here, so I think it will be a multiple of 6. R should be a multiple of 6. So that now you can approach, bachcho. Okay, so those were again the questions based on the general term, the application of general term of the binomial expansion. So now moving to the fifth question, what is it? Now that's again a very important part, the find remainder. So see, in case we have to find remainder, the approach is we try to write dividend, the base of the dividend. Okay, so we can change it by raising it to different power, like 3 raised power 303, we can convert it to 3 square, 3 cube, whatever. So we try to write this base of the dividend as closest to multiple of 7, closest to multiple of divisor. Okay, so what is it? So that's divisor. So the approach is simple. Try to express the base of dividend closest to the multiple of 7. Now you start counting in the power of 3. 3 square is like difference between 7 and 3 square is 2. So let's try one more. So 3 cube 27. Now it is closest to the multiple of 7, which is 28. 28 minus 1. So that's what we need actually. So our attempt is to get it as close as to the possible multiple of the divisor. The best part will be when you get it as plus minus 1 type, like we got here. If not, then we will go for plus minus 2 type of thing. Okay, bachcho. So now I will write it as 3 cube raised to the power 101, which is 27 raised to the power 101, which is 28 minus 1 raised to the power 101. Okay, now since power is odd and I prefer to write it in the standard form of binomial expansion, 1 plus x raised to the power n or 1 minus x raised to the power n. So I will write it as 1 minus 28 raised to the power 101. Of course, I will take minus out of this binomial expression. Okay, now see, if you expand it, bachcho, first term is 1 minus 101 C1 into 28 plus 101 C to 28 square minus dot 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 and C. Now if we have to divide all the terms, the entire expansion by 7, that means we can divide all the terms separately by 7. See, one thing should be very clear, we don't add or subtract the remainder separately, we avoid it, okay? We avoid it. I won't say we don't, but we avoid it. But here why we can do it? Because see, when you divide this by 7, 28 is a multiple of 7, so remainder is 0. So every other term except the first term will leave remainder 0. So the only term that will give remainder here is -1 when divided by 7. Now that's again an interesting case. So if dividend is negative and you have to find the remainder, what you have to do? You have to count in the multiple of that divisor and just add to the dividend the multiple of divisor which is just larger than the dividend magnitude wise. So magnitude wise this is 1. So the first multiple of divisor is 7 which is larger to it. So 7 minus 1 is equal to 6. That's the remainder. So to make my point more clear, I will take one more example. Let's say if I ask you to find remainder when minus 19 is divided by maybe 8. So again, see what I said, count in the multiple of 8 and get that multiple which is just larger than the magnitude of the dividend. So 8, 3, 24. 24 is just larger magnitude wise to minus 19. Add it to the dividend. And whatever is left is the remainder. That's it, bacho. Okay, so that was one case. Now see, I wrote one more question here. Now that's one thing which is which you should know as a result. Maybe if anyone want tell us in the comment box. I will try to clarify it with a separate short type of video. But here the result is, see, if these two are same and they are prime number, 107, 107. Okay, so the power here of the dividend and the divisor are same and they are prime number, then remainder is base. So the R is 5 here. Remember it as a result. For example, if I say find remainder when 4 raised to the power, अब 1 लिख दिया तो क्या लिखें, maybe 31 divided by 31. So remainder will be 4 here, bachcho, without any doubt. Okay, yeah, many of you would have done it as a part of theorem somewhere while preparing for like Olympiads, etc. But still, we can easily prove it with the help of binomial theorem, binomial expansion. If we go step by step, I'm not going into that much detail because what we need here is the result. If wherever required, we can use it. Now, let's come to this part. See. Now these are the, so those were the questions based on the general term of the expansion, bachcho, and its application. Now these are few questions based on the series, a basic series which you may come across, like sum of all the binomial coefficient. We already know it's 2 raised to the power n. We know NCR is equal to NCN minus R. We know NCR plus NCR plus 1 is equal to N plus 1 CR plus 1. Okay, so I'll be writing whenever required. Now see, that's the question which I got somewhere. I mean the similar question I got somewhere. Now how to solve it? Okay, so see, it's 2 upon 11 factorial. So it's written 2 factorial, which is same as 2. We can write it as maybe as 0 factorial, 1 factorial, depending what we need. And then 2 upon 9 factorial into 2 factorial, right. So 9 plus 2 is 11, 11 plus 0 is 11. Okay, so that's correct. So 2 upon 7 factorial into 4 factorial plus 1 upon 5 factorial into 6 factorial. The one thing common in all the terms is the sum of the terms which are there in the denominator, which is 11. If you would have observed, I was just keep counting those things. Okay, now see, I will multiply and divide by 11 factorial. What do we get? So we will get 11 factorial by 11 factorial into 0 factorial 2 times. I think most of you now would have got what am I going to do here. So what are these terms which I am writing within bracket, bachcho? Aren't they binomial coefficient? Which binomial coefficients they are? And what do they give us ultimately? So are we expected to solve them separately? Definitely not. So the point is that this should be a question which is based on some property. So 11 C C C O O O. Chaliye, it's I think I missed something. Okay, So 9 into 2, 7, 4, 5, 6, 9, 2. So it should be, I just framed that question. Let me do it. See, what we will write here is 11C naught. Okay, chaliye, let me do it. So 2 into 11C2, 2 into 11C4, and then 11C5. Okay. So now what I can write here is it's वो गड़बड़ हो गया थोड़ा सा, I think 11C0, okay, plus 11C2 plus 11C9. Neither we will get all odd nor we will get all even. I am really sorry. Okay, the point was to use that property, the sum of all binomial coefficient is equal to 2 raised power n, and then sum of all even binomial coefficient was 2 raised power n minus 1. Sum of all odd binomial coefficient is also 2 raised power n minus 1. I just wrote it thinking something else. I would have must be thinking something else. But if you allow me, then I can correct it here itself. Okay, then how can we correct it? Because 90, 12, 12C3, right. See, let me correct it. Just turn with you. Instead of 2 factorial, I will write here with, see, again, I will say the importance of this is like to have a question, to have an approach. Okay. So what we have now? So we had a choice. So 11 factorial, 0 factorial is also 1, and then it will be 2, right. Wait. So we will get this as 3 factorial, then this is as 5 factorial, and then 7 into 5. Okay. Then we don't need actually. Okay. We don't need this one. That's one more correction. So this series will end here itself. Okay, so this series will end bachcho here itself. So if I just shade it with black, wait. Now what do we get here? So let me just quickly remove it. So what do we get here? Now see, the sum of terms in the denominator of every term is 12 here. So of course now you know what to do. We will be multiplying and dividing by 12 factorial. Okay, so what do we get? In that case we will get something. Wait. Right. So we will multiply and divide by 12 factorial. So it's 2 into 12 factorial by 11 factorial into 1 factorial plus 2 into 12 factorial by 9 factorial into 3 factorial plus 2 into 12 factorial by 7 factorial into 5 factorial. Okay, now see, what will I write here? 1 by 12 factorial, 2 into 12C1 plus 2 into 12C3 plus 2 into 12C5. Now, can I write it as 12C1 plus 12C3 plus 12C5 plus 2 into 12C5, we know NCR is equal to NCR minus 1, so 12C7. So I am breaking it into 2. Similarly, 12C3 can be written as 12C3 and 12C9. So 2 times 12C3 is 12C3 plus 12C3. I am writing one as this, and similarly this will be 12C11. Now what is it? Isn't that the sum of all odd binomial coefficient in the expansion? So it is nothing but, so if I write it here, so it's 1 by 12 factorial, and as I said, the sum of all odd or the sum of all even binomial coefficient in the expansion is 2 raised power n minus 1. So superscript is n. So it's 2 raised to the power 11. Now a plus b, so a is 2, b is 2, b is 11, and c is 12 here. Put the value, we get it. Okay. So a bit of mistake, but I think you won't mind it because the concept, as I say, was important. Now that's another one. Now this is based on this property. Again, I tried to frame it based on this property. So it's n plus 1 c r plus 1 here. Now how to start that? See, 3c3 is 1. Okay, so I can write 3c3 which is 1 as 4c4. I've done that. So now combine these two. So NCR plus NCR plus 1 is N plus 1 CR plus 1. So here it will be 5C3. Combine these two. So it will be 6C4. Here it will be 6C4, 6C3 to 7C4. So we are moving in that direction. So last will be 10C3 plus 10C4. It will be 11C4. So that should be the answer of this one, okay, using this property. Now moving to the next one. Now that's, I think, the last one, but again a very important one. See, now so few of you may be thinking that it's a multinomial. Is it there in the course or not? No, it's not a multinomial. It's a simple application of identity statement and how to use it to get these values. See, when you write this expansion in this form, isn't that a polynomial? So that's an identity statement. This statement has to be true for every value of x, okay. So I will just write it as 2 times x raised to the power 5 minus 4 times x cube plus 1 raised to the power 20 is a0 plus a1x plus a2x square plus a3x cube till the highest degree power possible is 2500. That's what I have given, 100 x raised to the power 100, okay. Now see, if you need the value of constant in the expansion is a0. What you have to do, that I discussed quickly in a short video also, okay. So now put x is equal to 0. So you put x is equal to 0 in LHS, you get 1 raised to the power 20, and of course when you put x is equal to 0, all the terms are gone and you are left with only a0. So the constant term of the expansion can be obtained just by putting x is equal to 0. That's one thing. Now I deliberately use this one. See, one thing, see, we have to observe, we have to be very alert while solving the question. See, we can see that the minimum degree possible in the expansion is x cube. You can't have a term of x with power less than 3. So what will be the coefficient of x raised to the power 1? This has to be 0. Coefficient of x square has to be 0. So we don't need any special trick to find a1 and a2. So we have to be alert here. See, I'm not saying that in every question you are going to do it, but since that's not specifically mentioned, that is just based on the statement, that is identity statement, it's application type of thing, okay. So we have to be alert to get these few other things. So a1, a2 is 0, so this is nothing but a0, which is 1. Now let's coming to the last one here, which is sum of all the coefficients. See, what is it? So if you open it, it's a0 plus a1 plus a2 until a100. Okay, so what is it? Actually, this is sum of all coefficients in the expansion. So if in any means any expansion, you need sum of all the coefficients. Okay, the one step solution is put x is equal to 1 here. So put x is equal to 1 here. Where? Of course, in this statement. So if you put x is equal to 1 in RHS, you get whatever is desired, a0 plus a1 plus a2 and dot dot dot. So of course, when you are putting x1, you have to put on both the sides. So you put x is equal to 1 here, and that gives us the answer. So what's the answer? So the answer is 2 plus 3, 5 minus 1. So interesting, it's again 1. So that's again 1. So that's simple sheer coincidence. Okay, so that's it. So those, according to me, are the very important concept, the type of questions, okay, for the upcoming JEE mains examination. Bachon, with all the best wishes. I believe you would have been through the predictor paper which I have uploaded in our channel. Okay, those papers are important, those questions are again very important. Okay, so you'll again find one more paper which I'll be uploading for the first few shift, like 22nd and 23rd, because we are expecting, as usual, the easy paper on those shift. Okay, so I'll be uploading a easy paper along with solution. So do go through that paper before going to the examination hall. May God bless you all with all the best wishes from our entire team, from our YouTube channel. Okay, may God bless you all, bachon.